Welcome to what's probably the most important video in all of this material on sequences and series. So here we're going to look at lots of examples. We're going to look at a review of all the things we've done so far and point out the places where it's easy to make a mistake or where people tend to get confused and try to um, head off any mistakes as much as possible as you go through the homework where you're going to have to do series and sequences without knowing which section they came from. So, review question, right? Number one, what is a sequence? All together? If you're not sure, pause the video and think about it. What's a sequence? It's a list, essentially, right? Function whose domain is in was our technical definition, but in practice, it's enough to just keep in mind that a sequence is a list, right? What's a series? A series is a different object altogether. Series is a sequence added up, right? It's a list added up. So it's the difference between a list and a list added up. And keeping those two things separate in our heads is really, really important, as we'll see as we go through some of the examples. So we have what I often call the zoo, right? All these examples we've been doing. Geometric series, that looks like the sum of some a and then r to the k, where r is the common ratio. Telescoping series, p series, right? 1 over k to the p. Those will converge when the p is bigger than 1, right? 1 over k, the series, right? That is a special p series when p is equal to 1. It has the name of the harmonic series. A log q series looks just like a p series, except it has a log of k in the top. And it converges, well, the same rule is for p series, when the q there, the power in the denominator, is bigger than 1. And then we've had all these various tests: divergence test, integral test, direct comparison test, or baby comparison test, limit comparison test, zero infinity comparison test, ratio test, root test, alternating series test. Wow, that's a lot of tests. And so now maybe you get the full impact now of what makes this material so hard. If you run across a test, or not a test, a series in the wild, right? There's one, just like you would see on the exam or in your homework, where you don't know what section it came from. You don't know what to use. Notice it says which test or tests would you use. There may be more than one test that will work, right? There may only be one that works. And how do you know which one to use and how to do it? Well, the first most important thing is to know all the examples from that zoo we listed, right? And to know all the tests and how they work, because you can't use these tests unless you know what they are and how they work, right? That's first most critical thing. But hopefully everybody's got that part down by now, because we've done homework over all of these. So you've at least done the ratio test enough to remember how that works, and you've done the alternating series test enough, or you will before you jump into this part. Enough so that you got the how does it work down. Now we're down to figuring out, what do we do, right? Well, here are some hints. So if you run across a series and you're not sure what to do, right, try the divergence test first. Okay? If the divergence test works, we're done. It most of the time doesn't work, right? But if it doesn't work, at least it makes us think about the right things. Let me show you what I mean. In this example, if I were going to do the divergence test, I'd put my thumb over the sum, and I would just look at the sequence. Remember how I said it was super important to keep straight the difference between sequence and series, right? So we just look at the sequence, right? Not the series itself. The sequence, well, it goes to 0 because the power in the denominator is k to the 3 halves. That's 1.5, right? Bigger than 1. And the power in the top is k to the first power. So, oh darn, this sequence converges to 0. So the divergence test tells me diddly squat. Well, well, not quite, because it made me go through and dissect this sequence and go, what have I got where? Well, I've got a k in the top and a k to the 3 halves, 1.5, in the denominator. What does that look like, right? What does it think about? I got a 1 power in the top, 1.5 power in the bottom. So think about that. that kind of the reason this is working is the reason this sequence is going to zero is because the power on the bottom's bigger by a half. Oh, so this is kind of acting like 1 over k to the 1/2 power, right? 1 over square root of k. Oh, well, 1 over k to the 1/2 power, that's a p-series. I know it diverges because I know my list of examples and how all those work. So maybe this is acting like 1 over k to the 1/2. What kind of test would that be? Well, it looks a lot like a limit comparison test is what I should try here. So does that make sense to everybody? Everybody see the thought process I'm going through this? So as we're going to do several more examples. As we go through this, you might want to pause the video and ask yourself, what would you do? Right? Try to think through how it works, and then continue playing. I'm not going to work out all the steps because, of course, at this point, everybody has done limit comparison tests and ratio tests and root tests and all that sort of stuff a lot. So if you have questions about those, obviously you can email me or post a question to the discussion board, and I strongly encourage you to do that. But let's just look at some more examples and figure out, the hard part, which is what should I try? So here's another one. Okay? Um, well, what jumps out at you? So I'll pause for a second and think about what jumps out at you. Well, what jumps out at me is the big factorial in the bottom, right? That 2k in parentheses with the big factorial is going, hello, I'm a factorial. I've got an exclamation point to let you know I'm a factorial. and then that 7 to the 2k, that's number to a kth power there. This thing looks a lot like it's just screaming out, I want to be subjected to the ratio test, right? Now, of course, you could try doing the divergence test first to this one. The divergence test doesn't help because, remember, on the Tower of Power, factorials beat numbers to a power. So this sequence will go to zero. So the divergence test doesn't help here. But again, thinking through that, again, makes us think, oh, there's a number to a power, there's a factorial. That's a good first step because now thinking, where do I want to do if I've got a factorial? Well, that sounds a lot like the ratio test, right? Okay, what about this one? Well, same series, except now I've put in a -1 to the k, right? So this is, now it's just that -1 to the k is just a huge flashing light going, hello, I'm alternating, 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 alternating. So what would I do if I have an alternating series? Probably alternating series test. And of course the factorials win, right? They're bigger on the Tower of Power. So when you try looking at just this part, then I'm putting my pointer around, right? The 7 to the 2k over 2k factorial, that sequence is decreasing going to zero. So the alternating series test will tell us that this guy converges too. Okay, here's a new one. You want to pause for a second and think about what you do with this guy. Okay, right back or unpaused. Okay. You might try the divergence test here. You might try ratio test here, right? Again, the factorial looks a lot like a ratio test. If I saw this, probably knowing that the factorials and the 3 to the k, are highly susceptible to the ratio test, I'd probably just do the ratio test. If you do that, you want to try it real quick? Before we try it, pause it before I tell you what happens. Okay, right back. If you try the ratio test with this, what you should find is that the limit you get from the ratio test is infinity, which is bigger than 1, and this series will diverge from the ratio test. You could have tried the divergence test on it first, and here's one of those examples where the divergence test would have helped, right? Would have ended the problem, because who wins, right? On the Tower of Power, k plus 2 factorial or 3 to the k? Well, it's the factorial, right? K plus 2 factorial beats 3 to the k, so this sequence goes to infinity, which means from the divergence test, my entire series diverges. Okay, here's a tricky one. Well, if you watch the videos for alternating series, I think we actually did it almost exactly the same one. Maybe the 3 wasn't there inside the cosine, but it's not an alternating series because it's not going plus minus plus minus plus minus, but some of the terms are negative. So I can't just say, hey, it's a p series because I got a k squared in the denominator. I can't even say it's less than um, 1 over k squared because some of the terms are negative. What I could do is put absolute values. Absolute value here, put absolute value there, and now check to see if this series converges absolutely. And it does. If you flip back to the videos on alternating series, we talked about absolute and conditional convergence. You'll see this guy will converge absolutely. So obviously the entire thing converges, period. What about this one? Well, the divergence test is no help, right? Because this sequence is definitely going to go to 0. So other ideas? Well, would the ratio test help here? Probably not. In fact, I can guarantee what you get is 1 from the ratio test. So no, it's not going to help. Root test, not really going to help here either. You're going to get 1 again, and it's not really going to help. Um, well, what else, right? Could I do a comparison test or something? Well, the k in the denominator might make you think that it's acting like 1 over k, which would diverge, but there's a little bit more than just a k down here. There's a square root of log k. And so maybe that's enough to make it converge. It's not completely clear whether this is it's definitely smaller than 1 over k. So if I try to do the direct comparison test with 1 over k, this series is smaller. And so being smaller than 1 over k, which diverges, right, doesn't help. Right? So what tips you off here is there's a log of k. There's also a k in the denominator. That k in the denominator right there looks suspiciously like a du. Right? So if you'd seen this example a week or two ago, when maybe integrals were fresher in everybody's mind, and you kind of squinted and made those k's like x's, this would look a whole lot like integration by substitution. So when you see a log and a log of k, and there's also an extra k loose in the denominator, then maybe that starts to smell like substitution. This one's going to be one we want to do the integral test to. And of course, if we do, we get an integral of 1 over square root of u, right? And we know that integral will diverge. Okay, what about this one? Well, so my first thought when it came up on my screen was I've got the kth root of k, right? There's a kth root. Maybe I'll do the root test. Yeah, not going to help because I don't want to do the kth root of the kth root, right? That doesn't work. And the root test is a root, not raising to a power. So what would I do here? Well, probably the easiest thing to do here is just the divergence test. Because if I look at just the sequence, right, what happens? Well, of course, the 3 stays 3, but what happens to the kth root of k? Remember, the kth root of k goes to 1. So this sequence, okay, goes to 3 over 1, which isn't 0. So this series is going to diverge by the divergence test. Okay? Not a whole lot of other obvious things that would work here, right? Okay, what about this one? Well, maybe the most common mistake I see people make on a question like this is on an exam, is they don't look close enough. I mean, you'd be amazed how many people will write this down, and even if they write the exponent right here on the 3 to the k, notice that's a 3 to the kth power, whereas here this is 2 times k. So in the top it's 2 times k, in the bottom that's 3 to the kth power. That's very different functions, right? And so what happens is, though, you'd be amazed how many people either misread it or they're in a hurry and don't care or something, and they'll tell me that, oh, this goes to 2/3 by the Tower of Power. But obviously it doesn't. 3 to the k beats 2 times k, right? Because that's an exponential function in the bottom. 3 raised to the k power, right? So the divergence test doesn't help here at all because the sequence goes to 0. So what would work here? Well, probably the best thing, right, would be either the ratio test, right, or the root test. Right? The root test will be really good because the kth root of 2 goes to 1, the kth root of k goes to 1, the kth root of 3 to the k goes to 3. So if you do the root test, you're going to need a third, right, which is less than 1, so this guy will converge. Same thing with the ratio test. You get a third out of this. You could try doing um, something else, but it'd be really hard to come up with something else that's as good as the ratio test or the root test, or at least as easy to use. Okay, this is a really sneaky one. I really, really like this question a lot. So anybody who's still listening to the videos and hasn't given up yet, see, this one's a really sneaky one and a really cool one. That's a cosine of k times pi. Now remember we had a problem a second ago with a cosine of 3k that just makes pluses and minuses bounce around randomly. Right? Not literally randomly, but haphazardly. Right? So a bunch of numbers are positive, a bunch of them are negative, but it's not like they alternate. But this one, cosine of k times pi, what happens to that? If I take cosine of pi, that's negative 1. Cosine of 2 pi, oh, that's plus 1 again. Cosine of 3 pi, that's back to negative 1 again. In other words, cosine of k times pi is the same as negative 1 to the k. It's just another way of writing it. It's just making you go plus minus, plus minus, plus minus. Okay, so this really is a hidden, not very well hidden, but not obvious, alternating series, right? That cosine of k pi is making it alternate, plus minus, plus minus, plus minus, plus minus. So you can do the alternating series test. Or you could put absolute values around it and you would get 1 over 2k factorial and use the ratio test, what the book would call the generalized ratio test, right? By putting absolute values around it to see that this thing converges absolutely, in fact. Okay. I love this last example. This is a really, really good, really, really good example because a lot of things work here. So if you remember a second ago, we had an example with a log and a k in the denominator, and I said, oh, look, there's a k in the denominator and a log. That, if we were doing this, a while back, would look like integration by substitution. And you could do that here too. Okay? You could say that that k in the denominator makes me think of use substitution and do the integral test. And that will work. If you do the integral test, it will absolutely work. The derivative of log of k squared, well, it may not look like that quite works until you actually write down the derivative, because when you take the log of x squared, right, you take the derivative, you get 1 over x squared times 2x. So the x's cancel and you get 2 times 1 over x. So sure enough, when you do the integral test, this will work. And you'll get that it diverges. Okay. What else would work here? Well, does the divergence test work? No, not really, because the k beats the log of k squared. Oh, how do I know that it beats the log of k squared? Well, just like before we taking the derivative, maybe you could see this too. I could take that 2 right here in the exponent and bring it down in front. That's just algebra. That's not derivatives, right? So this is why the derivative of this is 2 over, the derivative of log of x squared is 2 over x. It's because I could take that k, that squared right there and bring it down in front. So it's really in the top 2 log of k over k. Okay, that's a pun. Divergence test doesn't help. What else might? Well, baby comparison test would work. Because if that log weren't there, if I just had 1 over k, that's the harmonic series, that guy diverges. By putting the log in the top, I've made this even bigger. So this would work with the baby comparison test. Right? What else might work? You could try doing the limit comparison test with 1 over k. What you'll see is that it doesn't quite work. What you end up getting is either 0 or infinity, depending on which one you put in the top or the bottom. And the 0 infinity test will work here. Finally, what you could do is bring this 2 down in front, right? Make this 2 log of k. And that would be a log q series with q equal to 1. So you just recognize it as a series that we already know how to handle. So there's a lot of different things you could do with this one. Ratio test and root test probably isn't one of them, but just about everything else works, right? I guess the divergence test didn't work, but most of the tests that you might think of trying work here. There's one reason that makes this material so hard. It's you run across an example where only the integral test will work, right? Or only the divergence test will work. And then you run across an example like this last one where there was all sorts of tests that worked. You just had to, you know, pick one of the ones that works. How do you do this? Well, you just have to do a whole bunch of them to get good at it. One of the things I love to ask on exams are discussion kinds of questions. So a question that says, what, like this one, what's the difference between absolute and conditional convergence? One of the things that I think as math teachers we failed at a little bit is we try to tell whether a student understands a concept by giving them a problem to work. And there's a difference between understanding a concept and working a problem about that concept. Right? Those are, if you're talk to people over in education, they have a taxonomy and lists and all sorts of um, cognitive neuroscience stuff that will tell you why that's different. But I think it's pretty easy to see that making you work a problem is different than asking you a question about the concept that the problem is over. And so one failing I think that we have sometimes is we just ask you problems and we don't say, look, just tell me about this. And so I love asking questions like this. What's the difference between absolute and conditional convergence? So we want to pause it for a second and think about it. So if you have a series and you put absolute values around the AKs, around the terms, and it converges, then it converges absolutely. If it converges but not absolutely, then it converges conditionally, right? That's the deal. And explaining that to two sentences, that's it. And if you can explain that, right, then you really understand it. Then you'll be able to work the problems correctly. It doesn't always work both ways, though. Sometimes people get used to procedures of how to work a problem, and if you ask them to actually explain something, they never thought about it before. So questions like this definitely could show up on exams. Right, here's another easy one, right? But what's the difference between a sequence and a series? Of course, a sequence is like a list. A series is the list added up. Right? Here's another great question, and we've had stuff like this in the homework, but this is worth pausing for a second so I can explain to you why I love asking questions like this in the homework. So suppose you have a sequence AKs, and they're all positive, okay? And then you have AK divided by 1 over K. You take the limit of that, and you get a half. Does the series AK converge or diverge? Okay, so what in the world is going on here, right? If you look at this AK divided by 1 over K business, you think about that for a second, maybe you recognize, oh, what we're really doing here is the limit comparison test, right? I've got the AK that I really care about, the series of AK. So I've put the AK sequence here. 1 over K is another sequence that I'm comparing it to down there. And I've taken the limit. And when I take the limit, I get a half. Okay? Now, this is why I love this question, because you have to stop and ask yourself at this point, when you try to do the limit comparison test and you get a half out as the answer, what does that tell you? Okay? The answer is it's not, a half is not 0, a half is not infinity. Right? It means the AK and the 1 over K tie on the Tower of Power. So it means the AK and the 1 over K series both do the same thing. Of course, the 1 over K series diverges. So the answer is the AK series diverges. Okay? Well, it was a lot of words to say all of that. But why do I love asking this question so much? Because you have to understand what the ratio test really tells you, and also because it lets me point out at this point, right, that a super, super easy common mistake for people to make. And it's this. A lot of times people will try to do the ratio test. They'll get through with the ratio test and the limit came out to be a half. And they look at the half and their brain skips a track. Okay? So back in my youth, well, we had mostly cassette tapes, but but there were still plenty of people around with record players. And so if you've ever seen a record player, which records are still a thing, we don't just use them to scratch and make scratchy noises. They really use them to play music. A record had a little groove, right? And what could happen is, especially if the thing was damaged, is it would skip from one track to the next. And so what can happen here is people's brains can skip a track. And so we're doing the limit comparison test. So what we do is we get the number at the end and see if it's 0 or infinity, right? As long as it's not, then we can use the limit comparison test. But sometimes people will see that 1/2 that comes out, and their brain skips a track and they go, oh, a half. That's less than 1, so it must converge, because their brain skipped to thinking about the ratio test or a root test. So this is why I love this question, because this happens a lot to people. So try to do the limit comparison test and they may get out 0 or a third or something like that and go, oh, it can definitely converges. Or they get out a 5 and they go, oh, it definitely diverges, because what happened in their brain switched from thinking about the limit comparison test to using the conclusion of the ratio or the root test. So be careful not to do that. Here's another great example. Um, so we have these, again, positive terms, right? We need that. But it looks like what we're doing here is the ratio test. I've taken AK plus 1 and divided by AK. And when I did that, I did the division, I got 3 over K. And the question is, does this series AK converge or diverge? So again, first off, notice it's the series AK that I care about, not this 3 over K or AK plus 1 over K, right? It's clear that what I'm doing in this fraction is trying to do the ratio test. Right? So sometimes when people are doing the ratio test, it's another example of how people's brain will skip a groove, right? So the right way to do this problem would be to take the limit of the ratio. Notice I don't have a limit written here. So I need to take the limit on both sides. So I'd have the limit of 3 over K. Now, that's a sequence. Remember how I made such a huge deal out of the difference between a sequence and a series? Right here on the screen, I've only written a sequence, 3 over K. So I take the limit of that sequence, and obviously the K is bigger, right, on the Tower of Power. So this sequence goes to 0. That means if I were to do the ratio test to the series AK, right, I would form this ratio, I would take the limit, I would get 0. So the right answer is this series AK converges by the ratio test. So far so good? Okay, the mistake that's easy for people to make is this one. They start trying to do the ratio test. They cancel a bunch of stuff, there's some factorial or whatever. At the end they get 3 over K. And maybe they haven't been writing limit all the way through and being careful about that. So they get to the end, they have 3 over K. And suddenly their brain skips a groove and they go 3 over K. Oh, that's a harmonic series. It diverges. But again, 3 over K is a sequence right here when I'm doing the ratio test. I'm not doing the series 3 over K. I'm looking at the sequence that I get when I make the ratio and do the ratio test. So that's the difference, and it's easy to get those confused. So how do you avoid that? Well, A, be aware of it, which is why I'm making this video. And number 2, just do as many examples as you possibly can so that you know, so also that you make all these mistakes, catch it when you look at the right answers, and then are able to go on. If you run across any questions doing these, you can always and should always email me, right? And post answers in the discussion board and so on, so we can go through these, because the only way to get good at these is just to do a bunch of them.